This section examines the rotor. It consists of a coil of wire wound on an iron core and pressed on a steel shaft. An iron segment is fastened on each side of the coil assembly so that the projections or claws interlace. The ends of the rotor coil are connected to insulated slip rings mounted on the shaft, and spring-loaded brushes maintain contact with the slip rings at all times. When a current is passed through the slip rings and the coil winding, it establishes a north and south pole at the ends of the iron core and the shaft. The projections then take on the same polarity as the end of the shaft on which they are mounted, and this forms pairs of north and south poles around the rotor circumference. The rotor usually has 8 to 12 poles, which are tapered to reduce noise as the rotor rotates. This section examines the rotor circuit. Current is provided to the rotor by means of the slip rings and brushes. When the engine is running, most alternators supply the field current directly by means of 3 extra diodes connected to the bridge rectifier circuit. Extra diodes are known as field diodes or excited diodes, and the alternator is said to be self-exciting. However, this self-excitation can only occur when the alternator is producing an output. When the ignition switch is closed, current can flow from the battery positive terminal through the ignition switch and charge indicator lamp to the L terminal of the alternator. The circuit is completed through the slip rings and rotor field winding, and through the voltage regulator to ground on the vehicle frame. The small amount of current flowing in the circuit illuminates the indicator lamp and provides the initial excitation of the field winding. This magnetizes the rotor pole shoes and produces a weak magnetic field. When the rotor is driven by the engine crankshaft, the rotating magnetic field induces a voltage in the phase windings, which is applied to the B-positive alternator output terminal. However, this voltage is also impressed on the excited diodes, and current can now flow directly to the field circuit, restricted only by the resistance of the field winding. This strengthens the magnetic field, and the output voltage rises quickly. The voltage regulator now takes over to control the field circuit current and maintain a preset regulated output voltage at the B-positive terminal of approximately 14 volts. As the voltage on each side of the charge indicator lamp is now equal, there can be no current flow through the lamp and the lamp is extinguished. The alternator is now said to be charging, and since the output voltage at the B-positive alternator terminal is greater than that of the battery, the current flows to the battery to begin the recharging process.